Big boy. Let me go over this real quick again. Absolute value is always a positive number because absolute value is the distance from zero on the number line. So the absolute value of 5 is 5. Absolute value of -5 is also 5. And again, it's the distance. Distance is always positive. So if you had the absolute value of P is 7, what could P equal? It could equal 7 or -7. And if you get this, absolute value of L is -5, the answer there is undefined because absolute value is always positive. And like that. Okay, I think last time we talked about the distributive property of multiplication. This is very, very important. Super duper whiz bang important. If we have 2a plus 4 times 3a plus 5. Miss Power, you've already been. Mr. Jimenez?
Yes.
Okay, what we're going to do here is how the parentheses makes this one number and this one number. But there's two numbers in there, but the parentheses makes it one number. So what we're going to do is, can y'all see my paper okay? Because I can't see this.
A little bit.
First, we're going to take the 2a and multiply it times everything over here. So 2a times 3a is
6a squared.
good. 6a squared. And 2a times 5 is, Mr. Jimenez?
10a.
Good.
Plus 10a.
Plus 10a. Now we do the same thing with the 4. 4 times everything over here. 4 times 3a.
12a.
Good. And 4 times 5 is
20.
20. Typically, the middle two terms, these are called the linear terms. They are, they're usually like terms. So we have 6a squared, 10a and 12a, was that 22?
22a.
I knew that. Plus 20. Is there anything else we can do here? No. I sent you a paper on what did I send you a paper on? Oh, factoring. When you first look at it, you think, oh my God, that boy's lost his mind. This doesn't make any sense at all. But I think you'll find it useful at some time. This, what we're going to do is when we're factoring is we're going to take this and we're going to change it back into this. It seems like everything we do in mathematics, we do frontwards and backwards. Okay. Now, remember, if you have a positive times a positive number is a, can you be more stupid? Is a positive number. A negative times a negative is also a positive. Now, these rules are the same for multiplication. Multiplication and division. And if the signs are different, a negative times a positive, or vice versa, that's going to equal a negative. Okay, this is for multiplication or division, either one. So what if we have, let's see, who's next? Mr. Zaroli, did you already go?
Yeah, I already went.
Okay, Mr. Luna.
I haven't went yet.
Okay, here we go. -3b, -3l for Luna. -2. They got these godless negative numbers in here. Times 4b minus 6. L minus 6. Okay. Now first we take the 3L, the negative 3L, I'm sorry, and we multiply it by times everything over here. Negative 3L times 4L is,
12L square.
I'm sorry,
12L square.
huh?
12L square.
No,
Well, you said 3L times 4L?
no, negative 3L
Oh,
times,
negative 12.
good, negative 12L squared. Now we have negative 3L times a negative 6. Negative times a negative is a
Positive.
good.
18.
And then 3L times 6, was it 18?
18.
18L. Now we do the same thing with the negative 2. Multiply it times everything over here. Negative 2 times 4L.
Negative 8L.
Good. Negative 8L. And negative 2 times negative 6 is
12.
positive 12, right? Again, middle two terms are common. So we have, excuse me, COVID's got me again. 12L squared. Okay, we have 18L minus 8L is, was it 10?
10 now.
10L plus 12. And that's all there is to it. Okay. Okay, these problems, they don't get any more difficult. They just get longer. So if you have 5C plus 2, whose turn is it? Mr. Luna just went. Ms. Caballero,
Yes, Professor?
are you ready? ¿Está
Yes.
listo? I don't know what that
Yes,
means. But
lista.
let's call her Caballeros.
Caballero.
That's right.
Caballero, sí. Manuela. Okay, we have 5 Manuelas más dos. I have no idea what I'm saying, but it sounds Spanish, though, doesn't it? Okay, times 3 Manuelas squared minus 6 Manuelas menos 4. Now, what the heck are we going to do here if you're so doggone smart, Miss Caballero?
Okay, let's try.
Same stupid thing, right? The only thing is we got more numbers over here, but it's
Right.
the same process. First, we take the 5M, multiply it times everything over here.
Right.
Okay, so 5M times 3M squared is
15 cube.
2. Good, excellent. M cubed, right? Because remember, what do we do when we're multiplying and we have the same base numbers? We
Yeah.
add the exponents. Now we have 5M times a negative 6M is
It's negative 30m square.
2. Good, excellent. And 5M times a negative 4 is,
It's negative 20m.
oh, yeah, I was looking at the wrong thing. Right, negative 20M. Okay, now we distributed the 5M times everything over there. Now we're going to do the same thing with the 2.
Okay.
I have to put my finger on here because I'm stupid and I'll lose my place.
Okay.
2 times 3M squared is
6m square.
very good. And 2 times
Negative 12m
2. Good. Negative 12M.
and negative 8.
Very good. Now look, I have to do this. Do we have any more M cubes?
No.
No. Do we have any squares?
Yes.
Here and here. I have to underline it because I'm stupid. How about any more M's?
Yes, we do.
Here
2.
and here. So we have 15 M cubed, negative 3M squared, and 6M squared is
It will be 3m square.
very good. Now we have negative 20M and negative 12M.
And with
Negative 32M square.
Very
No, M.
good. Just M, not M squared. Okay, we have the signs are the same. Negative numbers are kind of like owing money. So you owe 20 here, you owe 12 here. So how much do you owe? What was it, 32? M. And minus 8. Is there anything else we can do there? No. Like I said, they really don't get any more difficult. They just get longer. Everybody okay with this? I'm going to send you a copy. Is everybody been getting a copy of the YouTube video?
YouTube video. I don't think I got it.
I sent it to everybody, including myself.
Let's see.
Okay, these are okay. The next thing are conjugates. Miss Caballero, Miss
Um,
Shababo.
Professor, I only received the factoring sheet.
I'm sorry. Say that again.
Oh, sorry. Just wait a minute. Like the last mail I received from you is factoring terminals, something, but I didn't receive the link or something.
Okay. You should have gotten last. I think it was probably Friday morning. Is when I finally got that and sent it out.
Okay,
That
I'm
was
gonna look for it.
a link, a YouTube link.
Oh, yeah, that was on Friday.
Was it Friday? Okay.
Yeah, that was at 10.
And it's a link to YouTube. I record these and then I put them on YouTube for you. So
Okay,
if you
thank
don't
you.
get it, I'm sorry.
No, thank you.
Okay.
I'm gonna look for it.
Okay. Miss Shababo,
Here.
am I saying that right?
Yes, you are.
Okay. Let's see. These are called conjugates. This is important. You're going to see these and they are your friend. Conjugates. It's the difference. Conjugates are the difference of two terms. And I'll show you that in just a second. But right now, this is not super whiz bang important, but later on, this is going to be a real help to you. So what if we have this, Ms. Shababo? 3 Shababos plus 5 times 3 Shababos minus 5. Now, if you'll look, this is the difference is the when you subtract, right? These two terms are exactly alike. The only difference is one's plus and one's minus. Okay? And Ms. Shababa, what do we get here when we multiply these? First, the 3c times 3c.
9c squared.
Very good. 9c squared. 3c times negative 5 is?
Negative 15c.
Very good. Negative 15c. Now we're going to do the same thing with the 5. 5 times everything over here. 5 times 3c is?
Positive 15c.
Very good. And 5 times the negative 5 is?
Negative 25.
Excellent. Now look at these two terms here. This is on that sheet I just sent you. This is called the quadratic term. We're going to use these terms some. This one's called the linear term, and this is a constant. Now, what happens to this, Ms. Shababa?
It cancels out.
Excellent. They cancel out, right? 15c minus 15c is 0, gone, eliminated. So we end up with 9c squared minus 25. This is called a conjugate because everything in here are perfect squares. 9 is a perfect square, c squared is a perfect square, and 25 is a perfect square. And it is the difference. Okay? When it's the difference of perfect squares, and this is called a conjugate, and the linear term, the middle term, gets eliminated. Now, what happens if I ask you to factor this? Get this if you're so smart, Miss Shababa. What if I have 9c squared plus 25? Get that if you're so smart.
That one? That's harder.
No, you can't factor it. This is, I'm sorry, I'm kind of sandbagging you here. This is, my brain's gone numb. You can't factor it. It is come on, stupid think. I'm sorry, but my brain slips in and out of gear, especially right after summer.
A couple of drinks.
A couple of drinks. That's what's wrong. Prime. I'm sorry. In other words, it cannot be factored. Okay, so the answer to that is if it's the sum of two squares, this is prime. It cannot be factored. And again, that's called a conjugate. The name isn't that particularly important, but the concept is. Okay. Are y'all going to go to Dr. Martin and tell her that we leave early if we leave early?
Nope.
Nope.
It will be our secret.
Nope.
Uh-huh. I bet Miss Shababa will go over there and
No, I wouldn't. That's
tell
me.
poor Johnny. Poor
I'm gonna
Juanito.
stop being lazy.
He's a bad boy. Okay. Let's see. That was Miss Shababo. Mr. Islam, are you there?
Yeah, I'm here.
Can you hear me okay?
Yeah.
Am I saying your name right?
It's Islam. Yeah. here it is.
Islam. Okay. What if we have this? Get this if you're so smart. 4 Islams menos dos times 4 Islams plus dos. What do we have here, Mr. Islam?
You gotta distribute them. I don't
Yeah,
know.
but I'm not asking this. This is a conjugate, right? Because these are exactly the same. The only difference is one's plus and one's minus. Okay, 4i times 4i is
16i squared.
good. And 4i times 2 is
8i.
good. Now we do the same thing with the negative 2. Negative 2 times 4i is
Negative 8i.
good. And negative 2 times positive 2 is
Negative 4.
good. Now, the linear terms, what happens to them?
They cancel out.
Excellent. They cancel out. So it's 16i squared. I minus 8i is 0. It's gone. It's eliminated. Minus 4. So what do we have here? Two terms of the difference of two terms that are perfect squares. And what's that called? Excuse me. It's called a conjugate. Okay? Conjugate. What could be more fun? Okay, now we're going to kind of shift gears here a little bit. Who's after you, Mr. Islam? Mr. Garcia?
Yes, Professor.
If we have, now I would use S for Samuel, but my S's look like 5s. So I'm going to use M plus G divided by Z. Now the fraction bar kind of acts like parentheses, puts this as one number.
Mhm.
So what we're going to do is we're going to split these up into M divided by Z.
Plus G over Z.
Good. Plus G divided by Z. Everybody with me here? Okay, we have to divide each one of these terms up here by Z. So get this, Mr. Garcia. If we have 18 Garcia squared plus 12G divided by 6G. Now let's split this up. And what do we get, Mr. Garcia?
Can you move your paper up a little bit more?
Oh, I'm sorry.
That's okay.
Is that better?
Yeah, that's good.
Yeah. Okay.
All right, you get 18G squared over 6G.
Slow down, boy. I'm not that smart. Over 6G. Good.
And then plus 12G over 6G.
Good. Okay. Now 18 divided by 6 is what? 3?
Mhm.
G squared divided by G is
G.
good. Just G. Because remember, when we have the same base number, and we're dividing, we subtract the exponents. Plus 12G divided by 6G is
2G.
it G?
No,
Oh, sorry, just G.
Yeah.
Or just 2.
Good. Because G divided by G is G to the 0 power, which is
0.
1. Not
Oh.
0, 1. Now I'm glad you did that. Everybody, y'all need to remember this. G to the 0 power is 1.
Mhm.
Did I bore y'all with this before? What you're going to get on the final? You're going to get
Yeah.
16a cubed plus 43 b squared minus 16 g to the 5th plus 14 all to the 0 power. And what is all this misery?
1.
Excellent. 1. You're going to get that on the final. This is a gimme. Okay. Okay, and these problems, they really don't get any more difficult. They just get longer. Okay. Is everybody okay with this? You split each one of the terms up.
Yes.
Okay. Now factoring. This is important. They're going to irritate the crap out of you with this. Haven't figured out why, but they do. Miss Hardy, are you there? Miss Hardy? I see you there, Miss Hardy. Are you hiding from Johnny? I think so. Okay. Well, let's go back to the top then. Miss Lewis, are you still there?
Yes.
L plus 3 times L plus 5. What does this equal? First, we have the distributive property. Am I right or am I right?
You're right.
I'm right. I'm always right. I can hear my ex-wife's eyes rolling now. Hey, did I show you a picture of her?
No.
She's hot.
Let me see.
Okay. You don't believe me, Mr. Luna?
You're going to get me in trouble.
If you weren't so big, I'd smack you. Let's see. Where is it? No. 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 Where is she?
Hey, how many of them you got?
Well, you know how pictures. Oh, there she is.
What
Yeah,
is
but
that?
when we were in high school, she was easy. That's, that poor woman, my goodness. Whew. Come on, phone. Well,
15.
This is what she looked like before we got married. She was a real dog. And after we got married, it was looking like that. She was Garcia. I mean, Mr. Luna. She could take you 2 fouls out of 3. I mean, that girl was mean. Mhm.
I'll pass on that.
She was tough. Okay, Miss Lewis, we hadn't got all night. Come on, I got to get home and get my nap.
Uh, um, it's gonna be L squared,
Good. Uh-huh.
plus 5L,
Good.
plus 3L,
Very good.
plus 8.
Now we're multiplying, not adding.
15.
15. Okay. Middle two. That's why I want you to show your work if you can. Of course, on D2L you can't, but I'll be understanding about arithmetic. So we have L squared. These two are common. What is that? 8
Mhm.
plus 8L plus 15. Now, L squared plus 8L plus 15. Okay, now we're going to take this and we're going to factor it back into that. Now, how the heck are we going to do that? Miss Power. Where are you, Miss Power? Did she fall asleep? Miss Lewis, reach over there and smack her, will you? Okay. Miss Power. Who's Emma? Who's Emma?
Sorry, my toddler just walked into the room.
Oh, okay. Now look, what we want to do is we want to factor 15. We want to factor the constant. Now look, everything in here is positive. So it's going to be L plus something and L plus something. Now don't worry about it. If this doesn't make any sense right away, we're going to do so many of these that it'll make your ears bleed. Okay, what we want to do is we want to take the 15 and we want to find the factors of 15. Factors are what two numbers multiplied times each other give us 15. That will add up to 8. Is 1 times 15? No.
3, 5.
2, 3 times 5. There it is there, isn't it? 3 and 5 is 8. So we have 3 here and 5 there. Okay? And let's see. What if we have, whose turn is it? Mr. Jimenez? Why doesn't anybody want to talk to
Yes.
you? Okay, you there?
Yes.
Okay. What if we have this? What if we have a squared plus 13a plus 30. Now, again, everything in here is positive. So it's going to, our factors are going to be a plus something and a plus something. Now, we want the factors of 30 that add up to 13. 1 times 30, no. 2 times 15, no. 3 times 10, there it is there, huh? 3 and 10 are 13. Okay? What could be more fun? Okay. Who's next? Mr. Zaroli?
Yeah.
You ready?
Yeah.
What if we have x squared plus 9x plus 14? Now, what are the factors going to look like? Because everything in here is positive
It's gonna be plus.
and
Plus.
good. Both of these terms here are going to be positive. Now, we want the factors of 14 that add up to 9. One time.
X plus 7, X plus 2.
Good. 2 and 7, right? Okay. 1 times 14, 2 times 7, 2 and 7. It's starting to make more sense. Okay. I'll show you how to do this, how to get the factors. I'll show you how to do it on the calculator. Let's see. Okay, let me go over the vocabulary here for just a second. If we have x squared plus 9x plus 14. Now this is on that sheet that I sent you, so you don't really need to write it down unless you want to. This one is called the quadratic term. That's the quadratic term. We're going to use this vocabulary some. This one's called the linear term. And this one is the constant. Okay, quadratic term, linear term, constant. Not super duper whiz bang important, but you are going to see these terms from time to time. Now, look, I'm going to do this one frontwards and backwards. So if we have b minus 1 times b minus 8. Whose turn is it? Mr. Zaroli, did you just go?
Yeah.
Okay, Mr. Luna, what do we do here?
You gotta multiply them.
Good. B times B is?
B squared
Good. B times negative 8?
minus B8, 8B.
Good. Now we do the same thing with the negative 1. Negative 1 times B is?
Negative B.
Excellent. Negative B, and negative 1 times negative 8 is?
Positive 8.
Excellent. Middle two terms are common. So now we have?
9B. Oh no.
And we have B squared minus 8B. Stupid boy.
Is negative 9B, ain't it?
Well, yep, it sure is. My brain went numb again. B squared minus 9B plus 8. Now look, what did we have here? What are our factors? Both of the linear terms, both of the constants are negative. And if both of these are negative, the constant will end up being positive, right? So we're going to have, what's this going to look like? B minus some number and B minus some number, right? Because the last thing we do in the distributive property here is this number times this number. So now we want the factors of 8 that combine together to give us negative 9. We have negative 1 times negative 8. That's it there, isn't it? Negative 2 times negative 4. No, it's this one. Negative 1, negative 8. Because the linear term is negative and the constant's positive, it's going to look like that. Now, this one up here says smart. You just went. Mr. Luna, did you just go?
Yes.
Miss Caballero?
Yes.
Caballeros?
Yeah.
That's what my ex-wife would say. At Caballeros. Put an S on the end of everything.
It's okay. I'm used
I'm
to
going
it.
to Walmart's and then I'm going to eat lunch at Chick-fil-A. What? That girl was, oof. She was tough. And I don't mean good looking either. Okay, D squared minus 8D plus 15. What are the two terms going to look like here, Miss Caballero?
Both negative.
Excellent. D minus something and D minus something. Because the last thing we do is we multiply these two constants. We'll end up being positive. Now we want the factors of 15 that combine together to give us -8. So we have -1 times -15. No. -3 times -5. There it is there, huh?
Yeah.
-3 plus -5 gives us -8. Right? Right.
Yeah.
Very good. Let's see. Who's next? Miss Shababo? Have I put you to sleep yet?
No, I'm here.
Oh. This stuff would put amphetamine freaks to sleep. X squared minus 13x plus 36. What are the two factors going to look like? The
Negative.
linear term's
Negative.
negative and the constant's positive.
It's negative.
Thank you, Miss Shababa. You're very pretty tonight. Miss
Yeah, they're
Shababa.
gonna be negative.
They're both going to be negative, right? Because a negative times a negative will give us a positive. Now we want the factors of 36 that combine to give to combine together to give us -13. So we have -1 times -36. No. -2 times -18. No. -3 times what is it? 12? No. -4 times -9. There it is there. Right? 4 and 9. Mm-hmm. Now, what if what if we have this? E squared minus E minus 30. Whose turn is it? Miss Caballero, did you just, oh, Miss Shababo, you just went. Mr. Islam,
Yes.
what's this one? What are the two factors going to look like here? What will give us a negative in the constant? It's going to be E.
Positive and negative.
Excellent. Plus some number and E minus some number. A positive times a negative will give us a negative. So what are the factors of -30 that combine together to give us -1? -1 times 30, -2 times 15. No. negative 3 times 10, no, 4, negative 5 times 6. Will that give us negative 1?
Yes.
No.
What?
6 minus 5 is positive 1.
It
Oh,
would be
yeah.
-6 times 5.
Excellent. Who said that? Miss Caballero. She's going to be a troublemaker, Luna. You watch and see.
It's okay.
It's okay. Okay. Or we have we have 1 times negative 30. No. 2 times negative 15. No. 3 times negative 10. Okay, we have the positive and the negative. And then 5 times negative 6. That will give us negative 1 here. So what goes in the positive, on the positive thing here, Mr. Islam?
5.
Good. And on the negative side? Right? Right. Ooh, you see what time it is? 7:47. We need to take off.
Looks like you already did.
Yeah, like I already did. Okay. Okay. Let me do this one, then we'll go. You watch. Mr. Luna, you watch. Miss Caballero's going to go to Dr. Martin. Dr. Martin, that boy lets us go early. He's not working the whole time. Mm-hmm.
No, professor, never.
Yeah.
I swear.
Mm-hmm. H squared plus 10h minus 30. Get that one if you're so smart. Mr. Garcia, are you there?
Yeah, I'm here.
Okay. Now, what's this going to look like? If the linear term's positive, we really don't care about the linear term that much. But what's going to make this negative?
A positive and a negative.
Excellent. X plus something and H minus something. But what are the factors of negative 30 that combine together to give us a positive 10?
Well, if you want to start from 1, there's 1 and negative 30.
Yeah, like I said, I'm going to show you how to do this on the calculator, and it'll spit out the answer for you.
Okay.
2
there's 10,
times negative 15, 3 times negative 10,
10.
4, 5 times negative 6, and that's all, right? Or
Yeah.
we have the opposites. Negative 1 times 30, negative 2 times 15, negative 3 times 10, negative 5 times 6. Which two add up to give us 10?
Excuse me?
Which two of these factors combine together to give us positive 10?
Let's see. Positive 10?
None of them,
Yeah, none of them.
right? So
It's
what's our answer here?
undefined.
You can say that, but actually the answer, that's a good thought. It's prime.
Fine.
Cannot be factored. Just like the numbers 1, 3, actually 2, 3, 5, 7, 11. These are all prime numbers. The only thing that will, excuse me, the only thing that you can factor these into are 1 and the number itself. Okay? Like I said, we're going to do more of these, more of this factoring misery till it makes your ears bleed, because they love factoring on the final exam. Anybody have any questions?
No.
Oh, Johnny, why are you so ugly? Yeah, okay, yeah, I know. I have a mirror. Okay, if there are no questions, stand up, plug your chairs in, and go away. I'll see you Thursday.
Bye.
Bye.
Bye-bye. Y'all take care.
Professor.
Bye.
Try being good for a change.